Let fx is equal to px cube minus 150x square plus 4q, where p and q are positive integers. For how many ordered pair p comma q will x minus 3 be a factor of f of x? So I have given this function in x, that is p x cube, or it is a quadratic function in x 4q, where pq are positive integers. So I need to find the ordered pairs of p or q for x minus 3 to be a factor of this expression. I know from the factor theorem, I know if x minus 3 is a factor of this expression, if x minus 3 is a factor, then if I place x equal to 3, this expression should become 0, or x minus 3 to be a factor of this number, x equal to 3 must be a root of this expression. So for x equal to 3, this expression should turn to 0. So just writing or placing x equal to 3, putting the value of x as 3, it becomes 0, because x minus 3 is a factor, which is equal to, I have placed x as 3, so it becomes 27p minus, this is 9 is 1350 plus 4q. It must be equal to 0, so from here I get 27p plus 4q is equal to 1350, and from here I need to find the positive integer that satisfies this equation. So from here I can find when q is 0, p take the value 27 into 5, so p take the value 50, but I know this case is not possible because I have to find p and q are positive integer. So I have calculated, or I have placed q is equal to 0, because to easily get this one ordered pair for this equation, I will not include the solution because p and q are positive integers, so it is not valid. But for me now it is very easy to calculate all other ordered pairs of p by q, because it's a linear equation in two variables. I know this p will decrease by 4 units, or the coefficient of other variable. So this q, the value of q will increase by the coefficient of other variable. So it can decrease by 4. So next ordered pair will be 46, 27. Yes, it is acceptable. Next will be 42, 54. Is easily acceptable, and so on. So I can write the value of p as this expression 50 minus 4n. I can write 50 the possible values of p by placing the value of n as 0, 1, 2, 3 and so on, and I can write the value of q as 27n. So if I place n is equal to 0, it becomes 50. If I place n equal to 1, it becomes 46. If I place n equal to 2, it becomes 42. So I have to keep this value positive. So the highest value of n, so the highest value n can take is 12, because 12 into 4 is 48, and 50 minus 48 is 2. So p comes out to be 2. If I subtract further 4 from this 2, it becomes minus 2, which is again not possible. So for n equal to 12, p becomes 2, and for n equal to 12, this q becomes 27 into 12, so which is a acceptable case. So from n0 to n12, how many values are there? 13 ordered pairs. But I know this is not acceptable because q cannot take value 0. So correct answer to this question is, how many ordered pair are possible? 13 minus 1, that is 12 ordered pair of positive integer pq are possible. So correct answer is option B.